Hello, we are discussing about GATE 2015 ECE paper. Look at the circuit shown. Switch SW is closed at t is equal to 0. Assume 0 initial conditions. Find the value Vc of t, that is voltage across capacitor, at t is equal to 1 second. So find the value of voltage across capacitor at t is equal to 1 second if the switch is closed at t is equal to 0. And it is given that 0 initial conditions, capacitor doesn't have any value, so capacitor is uncharged before t is equal to 0. Okay, so this is a circuit, and we know the equation for a capacitor. Vc of t is equal to, while it is charging, V into 1 minus e power minus t by Rc. Rc is nothing but time constant. So this equation is valid for a simple RC circuit. For a simple RC circuit where you are going with voltage across capacitor is this one, and it is supplied with a voltage of V, and this is resistance value and it is capacitor. This equation is valid for a simple RC circuit when it is subject to a voltage of V. Okay. Now for the given circuit, if you are comparing, C is there, the rest of the circuit. Okay. This is the rest of the circuit. This rest of the circuit you must convert it into, okay, V into R, that is, that circuit is going to be converted into this block. So you are going to say it as Thevenin's equivalent, which is VTH and RTH. If you are able to get VTH and RTH across these two terminals, if you are looking into these two terminals, then find the VTH and RTH for this circuit and use those things and get the value of V and R. Substitute in this equation. You will get the Vc at any time. Then t is equal to 1 second. If you substitute, you will get the voltage across capacitor at t is equal to 1 second. Okay. So VTH first. VTH in our terms it is simply V. Okay. So that value is nothing but voltage across these two terminals, that is voltage across 2 ohms. So voltage across 2 ohms is 2 divided by 2 plus 3 into 10 using voltage division rule. So this is 20 divided by 5, which is nothing but 4 volts. And RTH, Thevenin's resistance, can be calculated, okay, by neglecting the voltage sources and current sources. If voltage source is present, it has to be short circuited, because voltage source is neglecting 0 volts. 0 volts is nothing but short circuit. If there is a current source, then it must be open circuit, because neglecting the current source is 0. Current source is 0 only when open circuit. So by making short circuit of this voltage source, you can see these two resistances are in parallel. So this is 2 parallel 3, which is nothing but 6 by 5 ohms. And now what we require is one more product term, RC. RC is equal to, R is 6 by 5 and C is 5 by 6. So this is 1 second. Okay. Now write those, substitute these values. So Vc at any time is equal to, V means 4 volts. This is 4 volts, and it is R is equal to 6 by 5 ohms and C is equal to 5 by 6 ohms. So V means 4 into 1 minus e power minus t by Rc is 1 itself. This is the voltage across capacitor at any time. So at t is equal to 1 second if you require. So Vc of t is equal to 1 second is equal to 4 into 1 minus e power. T is substituted with 1. 1 by 1 is nothing but 1. E power minus 1. So 4 times of 1 minus e power minus 1 means 0.3679. 0.3679, and this is 4 into 0.6321. 0.6321. So Vc at t is equal to 1 second is equal to 2.5284 volts. So this is the right answer. Voltage across capacitor is 2.5284 volts.